Hey there, FLEETtv. Good to see you again. Just in case we haven't met yet, my name is Raisa, and I am super excited to be here today, not with a joke or a Fleet fail, but actually to introduce some other members of our Fleet family. Today, I am super excited to be introducing you to our kid correspondents. Now, they all have some super cool activities, demos, and crafts for you to take on at home. So without further ado, let's get you all introduced to Ben, Truman, Jen, and Sam. Now, first up today, we actually have our friend Ben, who's going to be showing y'all just how you could make a treasure from the past. Y'all are going to learn how to make a DIY lava lamp. I'm going to be doing this one at home, so keep on watching to figure out how you can too.
Hello, I'm Ben from the Fleet Science Center, and today I'm going to show you how to make your own lava lamp. So the materials I have here are some vegetable oil, a clear plastic bottle, and some water I've already put food coloring in. I also have some Alka-Seltzer tablets, which I'll use later. So what I'm going to do is I'm going to put in the green water, it can be whatever color you want, in first. And then I'm going to put in the oil. As you can see here, the oil doesn't seem to mix with the green food colored water. That's because water mix and bond with water, and oil likes to mix and bond with oil, not vice versa. They do not like to bond or mix with each other. I'm gonna add these Alka-Seltzer tablets. Watch what happens. Now, when Alka-Seltzer hits water, it bubbles, which you can see here. The green colored water goes up, it comes down through the oil that does not like to mix with it, and we have our lava lamp. So, that's it. You can do all of this at home. You just need the following things I suggested, and you can create your very own lava lamp.
Alright, thanks so much for sharing that one with us, Ben. I'm going to be trying that craft, and if you guys do as well, please make sure to share it with us on all of our social medias. They will be right here, or here, somewhere, I don't know, wherever Corey decides to put them. Now, this next one isn't going to be a craft, but it's another project that you can tackle in a bottle. Now, I don't know about you all, but I have never seen a cloud form up close and personal, and our friend Truman is going to be showing you how you can make that happen inside a bottle with just a few materials that you probably have at home.
Hello and welcome to FLEETtv. I'm Truman, and today we're going to be doing an experiment that simulates how clouds are formed in nature. In nature, water droplets evaporate and cool down in the skies, making them condense into clouds. In this experiment, I will be using rubbing alcohol since it's more effective on a smaller scale. I will be building up pressure with a pump in a bottle with the rubbing alcohol in it, and then releasing that pressure to cool down the air and condense the evaporated rubbing alcohol, which was evaporated by the buildup of pressure. What you'll need is any pump that can attach to a regular bottle like this, some rubbing alcohol or water, your choice, of course the bottle, and optionally a temperature gauge to observe how the temperature is rising or falling. If it works, the temperature should lower. The way you're gonna wanna do this to set it up is you're gonna put about an inch of rubbing alcohol in the bottom of your bottle, then attach and seal the pump and make sure the rubbing alcohol is all over the sides of your bottle. And now I'm going to be demonstrating how to continue. You're going to pump it up till it's very difficult to continue pumping, and then you let it go and it creates a cloud in a bottle. Again, how this works is when we build up pressure in the bottle, some molecules of the rubbing alcohol evaporate. Then when we open the bottle, the temperature falls and the molecules cling to each other, forming a visible vapor or cloud. Thank you for watching FLEETtv, and this is Truman signing out.
Who knew just how easy it was to make a cloud? I sure didn't. Probably because I've never seen it happen before, but now you all know exactly how you can see it happen right in front of your very eyes. Super cool demo, thanks again for sharing, Truman. Now, keeping up with the sky theme, we are going to be exploring the power of air a little bit, and especially the Bernoulli effect. Now, to do that today, we are going to have Sam and Jen show off an experiment that you can also try at home. Take it away, Sam and Jen.
Hi, I'm Sam.
And I'm Sam's mom, and we're here with the Fleet Science Center doing science experiments that you can do in your own homes, because we're all in our own homes right now.
Yeah. So,
What do you have for us today, Sam?
all right. So, what I have are 2 experiments involving the stuff that's all around us, air.
I am so glad you said the stuff all around us, because a lot of times people think that the air isn't something, but the air is something. What is the air?
The air is a bunch of various gases.
That's true, the air is a bunch of various gases, but we want to think about them in terms think about them as tiny particles, right? So the tiny particles, they are all around us at all times.
Right.
Right.
And they're all pushing on us. So we can't really feel it, but they are all pushing on us. So let's take this can. And we have the straw. A straw. So this can, a bunch of air pushing on it, air pressure. So if I were to take this straw and I were to blow on the can, what would happen?
That's why we experiment.
It can't move forward because the air was pushing it in a forward direction, right?
Okay.
So right here I have my 2 cans on my various pencils. These pencils are all pretty much the same size and all round. You don't have to use pencils, you just pretty much need something round and the same size.
You can use straws.
Right. So, if I were to blow in between those cans, what would happen?
I don't know.
Well,
What do you think would happen?
You'd imagine it's gonna go apart because, you're pushing the 2 cans apart because the air is going in between them and it wants to expand.
That kind of makes sense.
So, let's see. Obviously, the cans did not go apart. In fact, they did the exact opposite.
No, you're right. They came together. Why did they do that?
Well, you see, because when you're blowing the air through the tube, air is moving really, really fast. The particles are going everywhere. They're going whoop, and fast. So all the particles around it are slower. And because the air is moving faster and all the particles are moving really fast, the slower, more slow air particles are pushing the cans together because they can.
Okay, that makes sense. Okay, what else do you have for us today, Sam?
I have an experiment involving a blow dryer and a ping pong ball
Head over to the air indicator.
and the air indicator. If I were to turn on this blow dryer, it's going to blow.
Okay.
So it's blowing very high and very fast this way. Go. I'm going to place this ping pong ball.
Alright.
When I start turning the blow dryer.
Air on the half, air on the bottom. Air on the half, air on the bottom. Alright, very good. Give us a quick explanation. What was going on there?
So the air around, as we could tell by the air indicator, the air on the top was moving very, 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 very fast. And because it was moving very, very fast, it couldn't really apply force downward. However, the air on the bottom was moving very slow, so it was applying a lot of force upward. This way, the air pressure ends with the ball floating.
Oh, nice. Thank you, Sam. That was a lot of fun. And you can do this and play with this with your own ping pong ball, and you can even make little relay races, things like that.
Yeah.
Make an obstacle course for your ping pong ball. All right, well, thank you, and hopefully we'll see you next time.
Yeah.
Now, I have to say one of my favorite parts of working at the Fleet is seeing kids in our museum or out at our programs learning and engaging in science, and it's even cooler to see them teaching science to other people. So a big, big, big thank you to our Fleet Kid correspondents again for showing off those awesome crafts, demos, and activities that you can try at home with your kids. Thanks so much for joining us today. I hope to see you again next time on Fleet TV. We'll see you around on our social medias as well, showing off all your science creations and activities, and we will see you most especially next time. Have a good one, Fleet TV. Bye-bye.